Next, let's talk about cross-blockchain bridges. While major blockchain networks such as Ethereum and Cardano aim to facilitate transactions and information verification using their own versions of blockchain technology, these separate networks are typically not compatible with one another. Information is not easily shared and transferred without an intermediary, such as an oracle. Some projects aim to create cross-chain bridges, which are essentially digital pathways to bridge the gap and facilitate the transfer of information between these ecosystems more easily. Some examples of cross-blockchain bridges are Polkadot. Polkadot is one of the largest projects working to create a cross-chain bridge. Its goal is to build a blockchain of blockchains, so to speak, where any and all blockchain networks can be connected and bridged through the Polkadot network. We also have Cosmos, or Atom. Cosmos is another project attempting to enable more data transfer between networks using what they call a network bridge system. So let's take a deeper look into how these blockchains are going about these efforts. So here's an example of how Polkadot works. This is actually from their white paper, and this is a schematic of how their network essentially operates, where the main chain acts as a relay chain, and essentially other blockchains can essentially dock and connect to this main chain essentially by facilitating transfer of information, where let's say Ethereum is connected to Polkadot and maybe information needs to be sent to Solana over here. Essentially now Polkadot can act as that intermediary, as that bridge where information can be relayed to the bridge into the other blockchain without any impediments. Taking a deeper look at Polkadot, here's an overview of their ecosystem. They're still building. It was only released, I believe, in 2020 as far as their mainnet launch. And their ecosystem is growing quickly, and it is beginning to start to rival Ethereum. It's not quite as developed, but it's still growing. And several categories such as asset management and wallets, validators, forums and explorers, oracle systems, lending and other protocols are still in progress and will continue to come and grow as time goes on. So here we see an image between two chains. Essentially, Polkadot and Cosmos will act as a bridge between these two chains, where let's say here's the Bitcoin blockchain and the Ethereum blockchain is here in chain B. Essentially, these blockchains can be thought as islands or different ecosystems, and information can't necessarily be easily transferred between them. These up-and-coming blockchains will essentially serve as these interconnectivity blockchains and promote greater use between these different systems. Next up, let's talk about scaling solutions, sidechains, and layer 2. So as a blockchain sees increased network activity, this could be increased transactions and use. It can suffer from network congestion and scaling difficulties. Layer 2 scaling solutions refer to a secondary chain that can help alleviate network congestion and improve transaction speed. Some examples of blockchain scaling solutions are Polygon, the OMG network, the Loom network, and Scale. So here are some examples of how these scaling solutions actually work. So focusing on the center, here we have our main chain. This could be Ethereum, maybe Solana, Cardano, and these main chains can be deemed secure and serve general purposes. Now, if they become overloaded and too many people are using them, they can become slow, where transactions are slower or possibly fees go up because so many people are using it and the transaction confirmation times are overloaded. Sidechains essentially act as a bridge to kind of offload some of those transactions to help accommodate the main chain. So here we see our side chain here on the left, and essentially a two-way bridge where information can be sent, transaction information, other applications and whatnot. Information can essentially be sent from this two-way bridge off the main chain to the side chain. They can be processed, and essentially that processed information can be sent back to the main chain. Now, the benefits of the side chain is that it has its own consensus mechanism, meaning that it's not waiting for all the nodes on the main chain to approve the transaction. It has its own approval mechanism. It's great for a general purpose. Now, along with that, it's also much faster. It can be deemed much faster than the main chain. Now, one of the potential negatives is that it has its own security model. So it's best to make sure that the side chain that's used is proven and is valid, as it technically is its own chain operating within the main chain. ZK rollups offer similar capabilities where data is periodically saved on a separate chain. It's as secure as the main chain, and it's typically has a general purpose and is deemed as fast as a side chain as well. Now moving on to forks. So a fork in a blockchain is essentially a split where a second project emerges from the original. This could be the result of members of a development team having a disagreement on the direction of the original project. A significant change in how the network operates could be proposed that splits the blockchain into two, where one network follows the old way of doing things and the new one follows a new set of rules. One part of that team may decide to go forward with their alternate vision and replicate the history of that blockchain up to the point, and then go forward with their new direction. Examples of cryptocurrency forks or splits include Bitcoin to Bitcoin Cash. We saw Bitcoin to Litecoin, Litecoin to Dogecoin, Ripple to Stellar Lumen, and Ethereum to Ethereum Classic. There have been many forks of Bitcoin over the years, and here is just a short, smaller example of essentially Bitcoin's family tree. These are all different projects that have forked from Bitcoin's original schematic, Bitcoin's original blockchain, and this could be due to a number of reasons, such as possibly development disagreements, maybe even disagreements with how specific blocks are added to the blockchain. So within that, we see Litecoin, Bitcoin Cash, Bitcoin SV, Zcash, Dash, and more. And even within Litecoin, if we follow this family tree, so to speak, we can trace the Litecoin's descendants all the way down to Doge. So Doge is essentially a fork of Litecoin, which is a fork of Bitcoin. Now within forks, there's hard forks and soft forks. So a soft fork essentially could be a disagreement with the size of blocks added to a blockchain, where let's say previously there were 2 megabytes per block added to each block on the blockchain, and perhaps certain validators, certain nodes only wanted to start adding 1 megabyte blocks, so smaller blocks, that way they can add them faster or so on. Essentially, this could lead to a soft fork, which essentially allows that these nodes or these validators operating under this new protocol where they're going to add smaller blocks can still interact with the main chain, and there isn't necessarily a disagreement. It's just different, essentially a different protocol on how consensus is met, how data is added to the blockchain. It's not a full-on disagreement that the project is split in half. Now, a full-on disagreement would be a hard fork, where essentially the original blockchain and these non-upgraded node blocks would follow the old protocol rule. So let's say the original blockchain would follow maybe a 2 megabyte limit per block. And then the new protocol in a hard fork could essentially lead to maybe those blocks only following a 1 megabyte per block protocol rule. So there is no interconnectivity between these two chains. They can't communicate or agree on these new protocol rules. So essentially one grouping of blocks of nodes follows one protocol rule set, and the other grouping of nodes follows a completely different protocol rule set. Moving on to file storage and file sharing coins. So certain cryptocurrency projects aim to revolutionize digital data storage and file sharing through the use of decentralized blockchain technology. The decentralization of data storage can allow for cheaper storage rates for all and more efficient data transfers across the globe. Some examples of these kinds of coins are Filecoin, BitTorrent, Storage, Siacoin, and the Ocean Protocol. So here's an example of how Filecoin works. So essentially, we have our user here, and the user pays a miner to store their file. So instead of using maybe a Google Drive to store your pictures, you want to use a decentralized protocol such as Filecoin. So the miner will publicly commit their informational services or their storage, their processors, by using Filecoin's blockchain to store the data on their servers. The Filecoin network will constantly verify that the miners are storing the files correctly, that they're not tampering with anything or maybe going into it. And the user will pay the miner to retrieve their file back again. Essentially, instead of mining graphics cards or ASICs like you would in a Bitcoin mining procedure,